David, thank you so much for inviting me to participate in this interview and learning experience. It's going to be a learning experience to me as well, because every time I talk to people, I learn something new because it makes me think. Uh, I really value our growing relationship between Walk with a Doc and Samuel Waxman Cancer Research Foundation. And I hope we'll have time to talk about that because I think your viewers would appreciate where we may be going together. So how did I get into medicine? You know, all of these stories are very personal. Everyone has a story, and this is a real story. I'll shorten it by saying that it was my goal to find my way. Because being, hate to get into the politics, but a person who's a child of immigrants, you often have to find your own way. And I found my way to Cornell University in the College of Agriculture, pursuing being a veterinarian. And for a lot of reasons, but no good reason, although I like science. Long story short, um, after my first year as an undergraduate, my mother passed away from cancer. And one thing you did not mention, that a good part of my career has been a hands-on clinician. And I've been taking care of patients with cancer for a long time. And it was always my first priority and my greatest satisfaction to be able to be just like you. I understand what it is to take care of a patient that's sick. And I think a lot of that had to do with my mother's passing, being very young at the time, totally unprepared, and never was told she was going to pass. And I guess we've changed. We've become more open about cancer as a disease we talk about. People look at it in a much better way than they did more than 50 years ago. So that's what drives me to get into medicine. There's a lot of other wrinkles into this, which you and I will talk about perhaps at a more time when we have leisure. And it has continued to drive me through all these years as a physician. And I went through many different specialty thoughts. I did internal medicine here at Mount Sinai. I looked at cardiology, which I thought clinically was more interesting, but the research didn't interest me. I looked at rheumatoid arthritis, and that was interesting, but not that interesting. And hematology really interests me because of the chance to really look to see the biology of diseases. So that's why I chose this.
It's great for everyone that you did. Thank goodness. That leads us to your developing a cure for a devastating form of leukemia. I can't wait to hear. I've not heard this story yet, so I would love to hear from the man himself on how this came about.
I'll try to keep it short, but I believe this is one of the great stories that we will have to write about in greater detail another time. So how did I get into this whole thing with leukemia? My research training, while I was a fellow in hematology at Mount Sinai, was looking at a form of an anemia called pernicious anemia. And for those of you who don't know what that is, it is a sneaky anemia that goes on to, before the cause was known, goes on to wiping out your bone marrow function and other things. And it was one of the major causes of death at the beginning of the 20th century, more than leukemia. And it was pernicious because it was subtle, not understood, didn't have a treatment. And with that diagnosis, it was a death sentence. So in studying pernicious anemia and the vitamins B12 and folate, it was so amazing as a hematology. If you looked at a bone marrow that was deficient, now that we know pernicious anemia was due to a B12, they didn't know from B12 at the beginning of the 20th century, being a vitamin required to make cells normal functions happen. So it's required to get the information biochemically that makes DNA happen. And if you can't make DNA properly, the genes get all messed up and cells just do not mature properly. And so I was fascinated by the bone marrow because you looked at it, it looked like leukemia. The cells were bizarre, they were big, they were primitive. And if you looked at the peripheral blood, a good hematologist would scratch their head and say, my goodness, this is leukemia. And that's really how it acted. So I studied that for a number of years and I became pretty rapidly well known in the field. It led to looking at therapies to block B12, block folic acid, antifolates. But I was waiting for the day we could find a model for a new pernicious anemia. Simple as a simple gene function that would interfere with a vital metabolic function. And so I'm working on my grants. I had grants in looking at B12 and folate here at Mount Sinai, and suddenly someone came running down the steps. I'm on the 3rd floor, and on the 4th floor, there is a very well-known virologist by the name of Charlotte Friend, who found a virus in her name that causes leukemia, and they're growing the Friend cells, which are red cell leukemias, erythroleukemia, in a test tube, in a plate. And they suddenly see that these leukemic cells had changed their appearance with unknown reason, and they looked like normal blood-forming cells. And more than that, they started producing a normal product called hemoglobin. Well, my goodness, these cells, something happened to make them differentiate into normal blood cells. And as it was a lab accident. Like great things happen. These cells were left in a preservative called DMSO, quite by accident. And when they were thawed out, you usually have to wash away the DMSO, the preservative, to carry on your experiment. The technician did not wash it away. And lo and behold, DMSO was able to be a chemical that caused differentiation of a mouse leukemia. When I heard about that, I said, this is differentiation as a therapy, because these cells became normalized, they stopped growing, and it was a great thing to study. So that was a lab accident. Then what happened after that was people started getting interested in differentiation as a possible therapy. And I think I played a reasonably important role in bringing that to attention. I was getting grants. I got other people interested around the world. We had conferences. And then they found a human leukemia cell line called HL60 in Bob Gallo's lab, which responded to vitamin A. Now that's curious. Why would it respond to vitamin A, a retinoid? And we just put it together as another agent that would cause differentiation. And there was good reason to have studied retinoic acid, vitamin A. And so everybody started studying that because it's a human cell line. And it looked like, well, we don't know, but it's so dramatic in the test tube in animals, why not try it in people? So it was thought to be an entity called acute promyelocytic leukemia. It came from a patient that was thought to have this form of leukemia, APL. APL, as a hematologist, was the most devastating acute leukemia. It was fatal, generally speaking, within 6 months, terrible complications, and our treatments in many patients often made it worse before they got better, if they did. So we're studying this, and I said, well, it sounds like we should, besides mechanism, try it in a person, a vitamin A derivative. So a couple of us here in the States went ahead and used the only retinoid that was clinically available, called Accutane. Now, Accutane is what you use for acne. Now, that's a crazy thought, right? Give somebody Accutane. But it wasn't so crazy. And so we gave people that, mainly the work was done at the University of Vermont by the head of hematology there. And he had a nibble. And he thought, well, it's there, but it's not causing remission. The cells did change, but clinical impact was minimal. And so by this time, I've entered into a collaboration with colleagues in China, which is a whole other story. What am I doing in China in 1988? It's a great story. And I continue to work with these people in China to this day. and we've had a lot of impact in growing programs there. So in our collaboration, it required me to go to make rounds in China at the Shanghai Second Medical University. And the director and also president of the university is a hematologist who never really had worked in differentiation. He worked in coagulation. But the people we had trained that came there went back to China, and they actually started looking at differentiation. And they got so intrigued in China, they made a different derivative of vitamin A. It looks just like Accutane, but it's just one thing is reversed. So it went from to all trans-retinoic acid to another derivative called ATRA, all trans-retinoic acid, 13 cis to all trans. And we're making rounds, and they said, look, we're giving it to patients and we're seeing a response, we'll get back to you. Within 6 weeks, or maybe 3 months, I got a manuscript from them showing that 15 out of 16 patients who, without any other treatment, went in complete remission. That's crazy stuff. Complete remission. And they looked at the bone marrows and the blood of these patients, these leukemic, nasty looking cells were normalized. And they gotten all the information that a normal, maturing white cell would do if they fought infection. And the best thing is, as they did their function like a normal cell, they died off. And in their place came normal cells. And this was a total great observation. So the next thing that happened is, again, what unknown things, it's predictable. It's very hard to cure anything with a single agent because there's always resistance. There are resistant cells. The stem cell is often resistant. Around that time, the science caught up with us. And with collaborations, and I was involved with this, we found the cause. It was a vitamin A deficiency due to a translocation or mess up in the gene segregation that broke a vital mechanism for vitamin A to work. So this translocation, single lesion, caused a block in vitamin A's job, so to speak. And as a result, even though the levels of vitamin A were normal, it couldn't be utilized for its role in making cells differentiate. So all trans-retinoic acid happened to be used in a much larger amount than the normal amount. It was 1 log more, 10 times more did the effect. So the other problem is that breaking part was not touched, the retinoic acid part, but there was another part to this translocation. Now, this gets more interesting. In the northern part of China, in a city called Harbin, am I taking too long, David?
No, this is fascinating. This
Maybe
is
you all like to hear the story. I don't want to just
no, this is
because it even gets crazier.
awesome.
The northern part of China, from in the 70s, as the rest of the country, they're having the Cultural Revolution. Now, imagine you're a doctor in Harbin, China, which is a pretty big city, very close to Russia, has the responsibility of treating all at the Harbin Medical University cancer patients. No Western medicine. You can only use medicine from the Chinese pharmacopoeia, and you can't hurt anybody because there's no malpractice. And if you do the wrong medicine, physically, you're in deep trouble. Physically. I mean, your world is over. So there is a particularly incredible guy there by the name of Xingtang So, who has this responsibility at the Harbin Medical University, and he has thousands of people to treat. And so he said, let me do something that's safe. Let's do something with arsenic. Now, everybody thinks of arsenic as a poison. Well, certainly that's not true. It's a fictionized thing, and too much is not good. But I guess, again, around the beginning of the 20th century, and you can go back to Hippocrates 500 years before, the single most drugged combination. It's into a compound we use what arsenic compounds. They were used for so many things. And when a doc went around with a bag, they would have an opiate, they would have digitalis, and they'd have arsenic. And that was it. And so they started using a special way of dissolving the arsenic, giving it by IV drip to thousands of patients. And in his log, he found out miraculously, patients who had APL responded dramatically, just like that. That's a chance happening. So word came down from Harbin to Shanghai, and we got involved in that. And they said, gee, people are relapsing, they're dying. Let's see what happens if we gave it after the retinoic acid. And in fact, everyone that got arsenic went into complete remission, like that. And we found out that's the reason very quickly, because the arsenic treatment actually degraded the other part of the broken switch. It took it out. Boom, it couldn't repress differentiation anymore. A totally new mechanism that is so important in everything else we do. So the combination of arsenic today, it's given by IV drip, but now there are oral derivatives that have been used in places like India and China, and it's coming here a little bit too late because the drug company probably want to make as much money as they can on the IV drip. Sorry I said that, but it's true, because using arsenic with retinoic acid together gives a 95% cure in this disease, because you're actually taking out the problem, the gene defect, and the arsenic, that part of the switch is vital to the stem cell, and it actually is taking out the stem cell that the retinoid couldn't. And that's why this is being cured. So what's the take home? One, timing, it just happened to be that way. Lab errors, I already told you about the chemical left in by chance. HL60, which we thought was from a patient with APL, did not have APL in retrospect, even though we thought they did. That was before we recognized the gene defect. And going back, these cells do not have it, which is crazy. The collaboration in China, getting a slightly different vitamin A derivative, which in the laboratory, we predicted it wouldn't be a good choice, but in a living person, it worked better. And finally, rediscovering an old drug like arsenic and putting it all together. So it's timing, collaboration, and luck in most good things in life. That's pretty much the story. The short version.
Oh, I believe it's the short, and I love the passion you bring it with us, like it just happened. And you took APL, which was a death sentence, to a greater than 95% cure rate, and changed just countless lives. So just fantastic. So your next endeavor, or should I say the most recent, is looking at aging in cancer. And, within cardiology, we think about aging and heart disease a lot. Do you mind sharing your thoughts? You bring such great passion to your answers. Thank you.
Right. So like any physician, and again, I'm a hands-on physician and I'm specializing in oncology. Toward the end of my career in seeing patients, I stopped that about 10 years ago to do everything else I do in a more leisurely pace, so to speak. It became clear that my patients were coming back with second cancers. The population that I was seeing was older. New cancers were arriving, age-related. So I started looking into this, and I took a deep dive pretty quickly, and it became clear that the incidence of cancer is increasing dramatically in our entire planet. And if you look at the incidence, so even though science is giving better treatments for cancer, less toxic, more targeted, as we speak today, immune therapy, everything we're curing more people, having them live longer with less toxicity. It's a big win. Truth be said, the incidence of cancer is rising. Now, you can't beat cancer if the incidence is rising. And it's definitely age related and not that different than cardiovascular disease, right? I mean, the incidence starts to really develop after 50, starts to get more and more. And the longer you live, the better chance you have of getting cardiovascular disease and dying from it. And the same thing with cancer. So on the cancer part, uh, taking all risks away, that there's certainly risks that add on to this aging situation. Aging is being studied separately from disease. So when I looked into that, there was virtually no, not fun, very minimal funding coming from the NIH linking aging as a cause of cancer. Very little. And so I used the Samuel Waxman Cancer Research Foundation to start to build awareness of this and get funding for it. And as a result, we have now made some progress in getting the NIH, specifically the National Cancer Institute and the National Institute of Aging, to start to fund collaborations in this. So that's what's driving me. And this is now backed up by extraordinary links that have clinical possibilities. And I'm happy to talk about that, but that's pretty much what I have been doing, the Waxman Foundation has been doing in forming partnerships to make this a more understood, get it into the clinic. Can we start to prevent this from happening if we have the right markers to see who's at risk with abnormal aging related to cancer development?
Fantastic. It's just so critically important. As a practicing oncologist, what do you recommend to your patients for cancer screening? And I wanted to get that in because I know it's important to a lot of us. And then I'd like to get some questions from our audience.
Well, that's a great question. You know, there is no one cancer test. You know, this rumor is going around. There's been some charlatans starting companies. Oh, we have the one test. You got to take this, get all your genes checked, and you're going to get cleared with your genes. You know, that's all part of the approach. I think as physicians, on the front line, there's some very basic things that are well known. Assume that education is an incredibly part of this. Education is an incredibly part, educating your patient population on knowing their family history. Family history is incredibly important because a lot of the gene mutations that we are found are important in developing cancer is something that is clinically evident by asking. So that's probably the first. And in the history, of course, correcting abnormal social behavior, or let's just say social behavior that does not work in your benefit. And they're clearly smoking, drinking in excess, obesity, conditioning, all important parts of screening, and I could go on, but they're not many. They're not many. And so as far as laboratory tests go, we're starting to get there. It's not prime time yet, but I'll bring this up now because you're going to hear more and more about this. Aging and cancer have the following link. There are essentially 3 mutations that we can track now, that if a person has these 3 mutations, or at least 2 of the 3, that this is associated with an aging population of cells. And it may lead to something called clonal development, clonal hematopoiesis. It's a term that will have clinical meaning very shortly, because clonal development means you're developing a special clone of cells that you can measure in the blood that have the potential to go on to cause cancer, whether it's blood malignancies, solid tumors. And these same three mutations are present in people with a higher risk of cardiovascular disease. The incidence goes up with age, starting around 50. And when you get to be over 80, about 18 to 20% of all people have these three mutations. And they're really interesting mutations because they're all targetable and will allow to have programs to follow them and also maybe mitigate them. And the question is, are these progressing because of obesity? You can test it. Does it has to do anything with smoking? You can test it. Breaking DNA, how we have these mutations, I can see where they would make your DNA breaks very bad. And so that's new stuff, but it's a word I want you to think about because that's where I think we're going to be in the clinic. Knowing what these mutations are, looking for clonal hematopoiesis will have impact in all forms of cancer and in cardiovascular disease. And then you can tell a patient, you know, we're not scaring you, but you want to mitigate that. This is a fact. It's common, you'll do well, but here's how you can do better. The rest are pretty clear. I am a firm believer in mammography. I think there's some of the people going out there to say the yield is small and you get unnecessary biopsies. As far as I'm concerned, one life saved is enough for me to justify use that. And it bothers me that some people are going around saying it causes more harm than good because they get a lot of unnecessary biopsies. Well, I think that's nonsense because you can beat breast cancer by early diagnosis, truly. The same thing with colon cancer. We got to take it seriously, and colonoscopy is absolutely critical, and family history should tell you when to start and never stop doing it. And because the incidence of colon cancer continues to rise. So you don't stop at a certain age. I'm going to get one. So that's another. PSAs, I still think PSAs are important. Again, the yield is small, unnecessary biopsies. Again, all you have to see is one patient with prostate cancer and you say, my God, I hope this will never happen again. So CT screening of the lungs, you know, simple screenings, like you screen for calcium in coronary artery disease, based on history. We have a history of smoking or living with someone that smoked or a family history of lung cancer. By golly, you should get screened, have baselines, and follow things. If you can make a diagnosis early of lung cancer, you can cure it. If it's late, big time, terrible time. So those are quickly, there are probably others, but that's the way I think about it.
There we have it, from a world famous oncologist. So you've motivated and inspired more than me. One of the questions from our audience has been, what has kept you motivated and inspired and acting like you're 25 years old here?
A lot of people ask me that. Unfinished business. So there are a lot of things you go into. We all have a lot of friends that made a lot of money. And, you know, you can measure it and you think that I've had enough and you can retire, or you have a service that you've provided and you've gone about as far as you can and it's finished. That would be okay. For me, I've got unfinished business to do. I think I still have something that I can bring that's impactful. And I go back to that episode when I was 16, not saying goodbye to somebody I loved a great deal. And this is a way of saying, you know, saving this goodbye and making it real. So those are all things that, and besides, I like it. I like what I do.
That's a great answer. So we have another question from the audience. My uncle had acute myeloid leukemia. He had a marrow transplant and was blessed to live 10 more years before contracting another case of AML and ultimately passing away. Our family's understanding is that it wasn't necessarily the leukemia that killed him, but rather his body could no longer fight infection, and the organs were overwhelmed by the bacteria and the strong antibiotics and steroids used to fight the recurring infections. Is that true? And is that the case for all forms of leukemia? I don't know if that's a fair question, but I'll.
Well, it's a fair question, and I'm sorry that you lost someone 10 years later. It's always sad to see that happen. And there's no simple answer to your question. The first thing to look at it, this person got 10 years. So let's look at the positives. That bone marrow transplant influenced a person with an average expectancy of about, if you're 50% are alive at the end of 2 years, it's a big deal, okay? And so having 10 years, I don't know what his state was like during that time, but by longevity, that's called success by any measure. As far as getting into the confounding situation of people dying from leukemia, leukemia itself is enough to kill you. The complications of leukemia are infection. The infection will overwhelm your body and your organs, and ultimately, why do leukemic patients die? They die from infection and overwhelming organ failure. That's the cause of death. And so the probability, that's what happened. And all of the effects of the antibiotics and so on and so forth were tried to prevent that. So I don't think you can conclude that this was, you can say it was in vain, but don't implicate it as the cause of the demise, you know. Now, the other thing one would wonder, is this a new leukemia? Is this a different leukemia? Is there new mutations in it? And the probability after 10 years, this is not the same leukemia. And you might want to look into that to make you feel better. Because I said to you that once you've been treated and live longer, you've got a chance of getting a different form of cancer. This may be entirely different. But on the other hand, disease is unlikely to be leukemia. Cancer can often recur 10, 20, 30 years, the same cancer, to a patient who's been free of disease for 20 years, 30 years, 40 years. And so there are cancer stem cells that find a place to live in your body. And this is a major problem in cancer treatment. They may be there and you don't know it. And they live symbiotically, and things will happen with age that will activate them. And that's another problem we're dealing with. And so the foundation's very, I work with 60 investigators trying to understand how these sleeping cancer cells get activated and how we can prevent that from happening.
Thank you for that. We have a question from Jean. I live in a rural area now, and previously had lived in a similar area for much of my life. Cancer rates are higher than the national average, and it appears that part of the cause may be due to pesticides and herbicides used in these areas, as well as the use of different hormones in the growth and development of animals whose meat and other products make it into the food supply. Could you share some of your experience, knowledge regarding these things?
By no means an expert on this. I mean, this has been everyone's concern. The statistical evidence for this at times becomes compelling with pesticides, with pollutants, with environmental hazards. And so I really think we have to really support our Environmental Protection Agency. At times it's loosening up. And if anything, as an individual like you should stay on it and advocate. If there are pesticides, you should ask the EPA to investigate it. Hearsay is no say as far as I'm concerned. You have to have evidence-based conclusions. And so I think it's everyone's obligation to, if they feel there's something going on, let them get some investigations. And that's what the EPA is supposed to be doing. So I can't really comment on an individual situation. Hormones in animal situation and breast cancer has been suspect Can you produce some of these things in a laboratory? Yes. And so the laboratory evidence, if you're really looking to prove a point, you really can't use the laboratory evidence because they're artificial studies. They generally use amounts of hormone in these studies that are way beyond what you'd be exposed to in a lifetime. The same thing with pollutants and pesticides. So to translate that into the real world has always been confounding to me, okay? So as far as a clinical solid evidence, I think it's lacking, but there are some clinical evidence, I should take that back, that are clear, that we have to deal with, and they are being dealt with by the EPA and others.
We've got a bunch of questions. Are you okay if we keep going with 2 or 3 more?
I'm all right.
Okay, great. So Polly asks, we often think of leukemia as a childhood disease. How many adults are diagnosed?
Well, when we talk about leukemia, I think you should understand leukemia is a generic term for lots of different clinical entities, lots of clinical entities. Childhood leukemia is a clear entity and has a different type of leukemia, and it can happen very early in life, and it has a whole different clinical course, and it peaks around in adolescence. And so that type, called ALL, starts to vanish by the time you're 25 or more or less. The good thing is it's not terribly common, but most of all, it's a highly curable form of leukemia in children. And we're really doing well with that. The other form of leukemia, which is much more common, is the myeloid leukemia, which again has multiple types, starts to peak, generally starts to be recognized at age 50 and above, and keeps going up with age. And we're seeing more and more of it because of living longer. And that whole entity has many different forms, many different subtleties associated with acquisition of mutations, lifestyle, and so on and so forth. And we're still dealing with that, with a much more difficult disease to cure and even manage, because genetically, the gene information is much more messed up than the childhood ALL type.
Thank you for that. 2 other questions. What was your most difficult as well as rewarding lessons? That's a deep one.
I guess it's something that I tell my grandkids. It's getting past no to get to yes. Right? I think everybody here has to keep that in mind. I had a lot of no's early at my beginning for a lot of reasons. And so I learned to deal with the no in order to get to yes, rather than get into one after another. I think recognizing that is the challenge in everything you do.
Wonderful. Where do you see BMT, CRISPR, and stem cell technology and treatment for leukemia and childhood cancers?
That's, surely many forms of cancer and leukemias are benefiting from bone marrow transplant. And the ability to develop BMT is challenging because you're really dealing with a graft, and complications of giving a graft to a recipient by itself is a real challenging clinical thing to deal with. We're learning how to do it better. We're learning that you can do it in a person that's 75 and 80 now, which no one ever thought that would happen. And so it's life-saving in many different situations: childhood cancer, leukemia, lymphoma, Hodgkin's, many of these things really has made a difference, multiple myeloma. So properly done by experts, BMT is really important. As far as stem cell, of course, keep in mind that today we don't harvest bone marrow, we harvest stem cells from the blood. Just like giving blood with an IV, you're giving stem cells. and therefore one can use them for the purpose of repopulating the bone marrow. Let's not confuse that you just can't take stem cells, put them in, and make an organ. You can't get your knees better with stem cells, from my point of view, clinically. It's proven, though, to repopulate a bone marrow. I don't know any other use, and it's commonly used today. So when we talk about BMT, it's really stem cell transfusions, which is neat. You don't have to be stuck 100 times in your bone marrow. As far as CRISPR goes, that is incredibly exciting. The technology is now available in almost every lab. My research, we do CRISPR technology. It is really allowing you to edit gene information. We're going to see this in one way or another in certain disease entities. One of the real great ones that are coming along quickly, similar to CRISPR, but at least gene therapy, is in sickle cell disease, which we're now using clinically, and I'm told some impact. Hemophilia, single gene problem. You can CRISPR it, correct it. I think we're in for a lot of things there. Several neurologic disorders due to single things. Cystic fibrosis is another. So I think either gene therapy or CRISPR not only is going from the lab to patients relatively quickly, but carefully.
Wonderful. So definitely optimistic stuff on the horizon. We've got about 10 minutes left. I would love to talk about a collaboration that we are doing with the Sam Waxman Cancer Research Foundation called Global Walk to Flatten the Curve of Rising Cancer Incidence. And at Walk with the Doc, our team has put together a virtual walk that was just an absolute blast, where we can record activities that we do, whether it's walking, running, biking, cooking. We get credit, and all that money goes towards a great cause. And that's exactly what Dr. Waxman and his wonderful organization is doing. I've signed up. I am ready to go. It's I got to wait a month. It's June 30th to July 10th. It's a great way to get us active. And I don't know if you want to touch on that, or the incredible event you have on July 10th, the Hampton Happenings, which has been going on, my understanding, for, is this going to be the 16th year, maybe?
Right.
Yeah.
I think, thanks again for bringing that up. For those of you who listening, and others who will hear this at another time, this global walk has not been done, really. It's ambitious. We get enough people and enough steps. We hope to get around the world, and participants should get the joy of being part of it. And we're also trying to fundraise through this walk, where each participant can give a challenge to their family and friends. And it's always been my thought to get kids involved and get their parents and grandparents involved. And it comes from learning about Walk with a Doc that has been very helpful. And I think this rising curve is something that has to do with poor, healthy, not unhealthy aging. And so we want to bring awareness, as you have, David, and your foundation, about the need for healthy living, mobility, etc. And it hasn't really been properly communicated as a mechanism to diminish cancer with unhealthy living. So we want to get that across. And so the Global Walk is to try as much as we can to spread the word. That curve is going up, just like COVID went up. And if you recall, most of the people that died from COVID were over the age of 65, more so at 75, and they had evidence of unhealthy living. They had another medical condition, they may have been smokers, they may have been obese, etc. So it all fits. So the idea of healthy aging, from my point of view, is an important part of this walk as well. And it's an important part of what you do. And that's why we're excited to do it with you. So I hope we can get as many of you as possible to spread the word about this walk. And at the end of the time, at this thing we have out in Long Island is this Hamptons Happening, which is going to be an evening of fun, outdoors under a tent. Hopefully, the gods will be with us and the CDC as well. That we're entering into a new normal now, and those people who have been vaccinated should recognize that you don't have to wear a mask. You can go inside without a mask. And that's what the science shows us. And so here will be a time to celebrate the post-COVID new normal. And so we're excited about that. We're going to really talk about healthy living. We'll have healthy food and also drink, and maybe not so healthy, just a little bit. So we invite you to come along, David. You have an invitation. Anyone else, come join us.
Well,
That's on July 10th.
Wonderful. The timing is great. And I think it's empowering to all of us when you speak of that the cancer is, so many types of cancer are within our control to improve our odds significantly. Dr. Waxman, it's been an absolute honor. I want to give you the floor for any closing statements. We will be posting this on our through our channels, and we're also definitely going to be promoting our collaboration with the effort to flatten the curve with this awesome 10-day event coming up. Any closing comments?
I would just simply say thanks, David. Thanks to Rail, and thanks to the staff for working with us. I keep up your good work. It really does have impact, and hopefully we'll grow in this situation together over the next few years. I thank you very much.
Oh, I very much look forward to it. Arel, Rachel, Brian, thank you. And we will see you all next time, and definitely see you virtually at the walk to flatten the curve. Thank you, Dr. Waxman.
Thank you so much.
Thank you, Dr. Waxman, and thank you everybody for staying with us. In 2 months' time, we'll be having another of these webinars, and we will be talking about how your bladder can stop you from exercising and what to do about it. We've got an amazing urologist who's going to talk to us about it, and we're excited to have her share her knowledge with us. We're also going to be sharing the link to the global walk, and we encourage you all to participate and join in the fun and join in helping a worthy cause. So thank you so much at the end of a busy day for joining us and for your questions. Thank you.